this video, we're going to look at two integration by parts problems, and we're going to find solutions based on the formula. So this one, the first problem, is going to be the integral of x times the secant squared of x dx. In order to set this up, I need to split this up into two parts, one involving a function I'm going to differentiate and one involving a function I'm going to integrate. So we typically call these u and dv, the differential dv. In order to make the choice of which one is going to be which, we are going to pick one that we can differentiate easily for u, and we want to pick one that we can integrate easily or anti-differentiate easily for v, dv. So in this case, we know the antiderivative of secant squared, and so we're going to take that to be our dv. That leaves only one part of the formula for u, and so u is going to equal x. So the derivative of u is easy enough to take, and the integral of dv is also fairly easy to take, and this is going to leave us hopefully with something that we can integrate at the end of the day. Du is dx, and v is going to be the tangent of x, and that's it. So the formula we know combines the u's and the v's, and the du's and the dv's to come up with something that also still has an integral. The integral is going to be u times v minus the integral of v du. And so in this case, it's the integral of x secant squared of x dx is equal to x times the tangent of x, that's u times v, minus the integral of v times du. So the integral of tangent of x times dx. All I have to do now, because this first part of the function is already integrated, is integrate the tangent of x. And this is something that you can either remember or you can look up. But we end up with x tangent of x minus the natural log of the absolute value of the secant of x plus a constant c. The second integral I want to look at involves the integral of the inverse tangent of x dx. This is not a product. It only has one term. And so typically when this is the case, we can't split it up into two different parts of a product. And so if we don't already know the antiderivative, we take u to be the part that we don't know. So u is going to be tangent inverse of x. And then dv is going to just be what's left, which is just dx. The antiderivative of dx is just going to be x, and so that's easy enough. The derivative of u is something I should know, and in this case it's 1 over 1 plus x squared dx. And so I end up getting rid of the inverse tangent, which is hard to work with, and end up with something rational, which typically is easier. When I put things into the formula, I end up with the integral of tan inverse of x dx is equal to u times v, so x times the inverse tangent of x. Luckily this is in a place I'm not going to have to integrate. And then minus the integral of v times du. So I have x over 1 plus x squared dx. And with that extra x in here, the second integral, or the last integral I have to take, involves something I can substitute out. So I let u equal 1 plus x squared. This is not the same u as I used before. And then du is going to be 2x dx, which matches nicely with the rest of the parts of the problem. And so x dx is a half du. Substituting these into my different parts here, I end up with something that is a little bit easier to look at. I have x tan inverse of x, which is the part I don't have to integrate, minus, it's going to be a half integral of 1 over u du. So now the antiderivative of that is easy enough to take. I have x times the tangent inverse of x minus a half, and this gives me a natural log of the absolute value of u, plus the constant c. Substituting back in, my antiderivative is x tan inverse of x minus a half times the natural log of u, which was 1 plus x squared, plus the constant c. Technically, I don't need these absolute values around the 1 plus x squared, because the thing inside is always going to be positive. So when I write down my final answer, what I end up with is the integral of the inverse tangent of x is going to be equal to x times the inverse tangent of x minus a half the natural log of 1 plus x squared plus the constant c.